In this video, we're going to learn about orbital diagrams and filling them according to the Aufbau principle, Hund's rule, and the Pauli exclusion principle. So the Pauli exclusion principle states that for an atom in the ground state, electrons will fill orbitals in order of increasing energy. So let's say that we have, beryllium, for example. Beryllium has 4 electrons, and the first 2 electrons are going to fit into the 1s orbital, the lowest energy orbital. And then the next 2 electrons are going to fit into the 2s. And note that I'm putting 1 electron up and 1 electron down. More on that later. But those arrows each they represent 1 electron. And you might know from Bohr-Rutherford diagrams and the Bohr model, there are 2 electrons that can fit in the first shell and then up to 8 in the second shell. Well, we filled up the first shell with 2 electrons, and actually notice the 2s and the 2p, we have slots for up to 8 electrons. 2 here, 2, 2, and 2 would give us 8 among the 2s and the 2p. So that is the Aufbau principle. Moving on to Hund's rule. This states that every orbital in a sublevel will singly be occupied before any orbital is doubly occupied. So we're going to do nitrogen now, and nitrogen has 7 electrons. So for nitrogen, we're going to go like this. According to Aufbau principle, fill the 1s, then fill the 2s, and then we will put 1 electron in each of the 2p orbitals. This would be the way to do it. The way not to do it would be to do like this. And then double up here. Because look at it this way. If you are getting onto a bus, you wouldn't, if you were this electron, you wouldn't want to sit next to another electron when you could have a whole bench to yourself on the bus. Electrons repel each other kind of like people do. So this is not good. This is okay. Another thing, by the way, and this doesn't entirely fit the analogy with the bus seats, but you can't have it be where 1 electron is up and then another one is down. All the spins should be facing the same direction. So you want to have up, 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 or down, 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 but not some up, some down. Finally, we have the Pauli exclusion principle, which states that electrons occupying the same orbital should have opposite spins. So 1 up, 1 down. This is good. And what you shouldn't do is have 2 up or 2 down. This would be bad, because actually, if you had 2 electrons that had the same spin, they would be exactly the same in every single way. All 4 quantum numbers would be the same. They'd have exactly the same properties in every way. They'd be occupying the same space. They would be the same thing. Giving them opposite spins makes them different things, and so that explains the Pauli exclusion principle. Anyway, that's all for this video. Hope it's helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.